Hi everyone, this video is an exercise 13G question 7. So we have the curve equation y is equal to x to the power of 2 over 3 minus 2 over x to the power 1 over 3 plus 1. And in part A, we want to verify that C crosses the x-axis at the point 1, 0. So for part A, we just need to substitute the x coordinate of 1 into the equation. And if we get the y coordinate as 0, then we have verified that. So we just need to substitute x is equal to 1 into the equation. Then we have 1 to the power of 2 over 3 minus 2 over 1 to the power of a third plus 1. And this is equal to 1 minus 2 plus 1, which is equal to 0. So therefore, it's verified. So 1, 0 lies on C. Okay. Now part B, we want to show that the point A with coordinates 8, 4 also lies on C. Okay, so again, it's very similar. We just need to substitute x is equal to 8 into the equation. So we can write when x is equal to 8, then y is equal to 8 to the power of 2 over 3 minus 2 over 8 to the power of a third and plus 1. So 8 to the power of 2 over 3 is simply equal to 4. And here we have minus 2 over 8 to the power of a third is just 2 plus 1. So that's equal to 4 minus 1 plus 1. And the final answer is 4. So therefore, we have shown that also point A with coordinates 8, 4 lies on C. So therefore, A with coordinates 8, 4 lies on C. Okay, so far we have shown that C crosses the x-axis and also point A lies on the curve. So I mean C crosses the x-axis at the point 1, 0. Okay, part C, we have point B, which is 4, 0. We want to find the equation of the line through AB. So this is just a GCSE question, really. So we have a line AB, and B has this coordinate, A has this coordinate. So we just want to find the equation of the line that passes through the 2 points. So for part C, we obviously need to use the equation of a straight line, which is y minus y0 is equal to m times x minus x0, where m is the gradient. So we first need to find the gradient, and once you have found the gradient, then we can just substitute into the formula. So the gradient is the difference of y's over difference of x. So we have y2 minus y1. Or we can just write in a more general way delta y over delta x, which means the difference of y's over difference of x. So point A has coordinates 8, 4, and point B has coordinates 4, 0. So this is point B and this is point A. Okay, so to find the gradient, let's start with y. So 4 minus 0 over 8 minus 4, and we simply get 1. So the gradient is 1. Okay, now let's substitute. Let's pick the point 4, 0 and substitute that into the formula. So we have y minus 0 is equal to 1 times x minus 4. Therefore, the equation of the line AB is x minus 4. So line AB, or the line that basically passes through A and B. So now the next part is where it gets interesting, and it's a bit this question is a bit different. So it's not like the ordinary area questions, and you will see the reason. So in the next one, we want to find basically we are told that the finite region R is bounded by the curve AB and the positive x-axis. So AB is that line that we discussed. C is the curve. So we want to find the area of R. Okay, so for this question, we are not given the diagram. So it's better to try and sketch the diagram that's going to be relevant for us. First of all, in the exam, if you have a graphical calculator, then you can obviously use that and get the actual diagram and use that. But even if you don't, you still can sketch this, but you just need to use some different techniques, because as you can see, these are not like some well-known graphs like quadratics. I mean, they are kind of still well-known because they are sets, but still they are not, as clear as quadratics or cubics. Okay, so first let's just draw a sketch of the graph, and then once we have that, then we can consider part D. So in order to sketch the graph, let's look at the equation and let's try and understand the asymptotic behavior of this equation. So what happens as x tends to, for example, positive infinity? Because remember, C and the line AB, they are both bounded between the line and the curve, and also the positive x-axis. So that just means that we only need to consider the positive x-axis. So that's where the integration is going to happen. So we don't need to think about what happens as x gets negative. So let's just consider the behavior. So when we have plus infinity, so let's rewrite the equation first. So if you rewrite the equation as y is equal to the cube root of x squared minus 2 over cube root of x plus 1. So obviously, as you can see, the very first thing is that x cannot be 0. And the second thing is that we need to consider what happens as x tends to the infinity. So if x tends to infinity, as you can see, the first part is essentially going to tend to infinity, because if you just imagine that you have a very, very huge number and you want to find its cube root, and that huge number is a squared, and then you find the cube root, the answer is also going to be very, very huge. So yeah, this part tends to infinity, and this part tends to 0 because, again, the denominator itself tends to infinity with the same reason. But since the denominator is very huge, obviously when you have a huge denominator, the number is very small. So this part tends to 0, this part tends to infinity, and then here you obviously have positive 1. So this simply means that the curve is going to have some sort of shape like this, something like this, because essentially as x increases, ultimately y is also going to increase and tends to infinity. And another fact here is that the question was saying that so curve C crosses the x-axis at the point 1, 0. So that one is also another clue, which is going to be absolutely crucial for us. So here, there is only one x-intercept on the positive side, and that's equal to 1. And we just need to include one more thing, and basically we are done with the diagram. And that is the part that says we also have a second point, which is B, and that has coordinates 4, 0. And I mean, we both have A and B, so I mean both of them. We need to plot both of these points so that we can draw the line. So point A has coordinates 8, 4. Let's say here is 8, here is 4. And then here is also maybe 4 again. Sorry, let's change this 4 because the question says that point A lies on C. So that means, let's say if here is 8, then I know the graph is not very accurate, but here is the point 8, 4, because again, 8, 4 is the coordinates of point A, which is on the curve. So yeah, let's sketch like that. Again, the whole point here is just to have a diagram so we can use that to integrate. The goal is not to be very accurate, because this sketch is part of the actual graph. Okay, we now need to decide about b, but b is very clear because b has coordinates 4, 0, so b is just simply here. So this is a, this is b, and guess what? The question says that we have a line AB, or a line that passes through these two. So essentially, we are going to have this. And yes, so essentially, if you then read the question again, because this is the curve, this is the diagram that we need. So we just need to read the question again just to understand where is R, the region. The finite region R is bounded by CAB and a positive x-axis. Okay, so that obviously means this is the region R, because it must be bounded by all the three lines and curves, because this is the x-axis part, this is the line AB, and this is the curve. So that's the only place that's possible. Okay, finally, we have the diagram. In part D, we want to find the area of R. Okay, so to find the area of R, we just need to realize that the area under the curve from 1 to 8 is going to give us the total area, between the curve, this sort of dotted line, and also the x-axis. So the area of the curve is going to give us the total area. So let's just write like this for now, dx. So this is going to give us the total area. So the total area means the area of the green region, which is R, plus the white region. But obviously we want to exclude the area of the white region, so we need to take that away. So the area of the white region. So that's what we need to do. So the part that is for the area of the curve is clear. We just integrate the equation of the curve from 1 to 8. And then for the white region, as some previous cases, we have two options. We can either just, here we happen to have a triangle, so we can just find this area of the triangle by using the formula of that, and then just write that, because the area of this white triangle is exactly the area of this white region. Or we can also use the integration, integrating the area under the line. So we can use this integral that, the limits are 4 and 8, because this region is from 4 to 8, of the line x minus 4, because that's the equation of the line AB, dx. So yeah, we can either use the area of the triangle or just this integral. So for simplicity, I'm going to use the area of the triangle in this case, but if you work out this, you're going to get 8, which is exactly the same as when you use the area of the triangle, and you will see in this question. Okay, so now let's write down the actual integrals. So first we have the curve. So the curve has the equation x to the power of 2 over 3 minus 2 over x to the power of a third, or we can just immediately change this to minus 2x to the power of minus a third plus 1 dx. So that's the part for the curve. And for the area of the triangle, as you can see, so the base is 4, the height is also 4, so we have a half times 4 times 4, and again, as you can see, this is equal to 8. Right, so now to solve the integral, we just integrate. So the first step integrates to 3 over 5 x to the power of 5 over 3. So be careful with this fraction, because sometimes it's very easy to miscalculate them and have the wrong integral. For the next term, we have minus 2x to the power of minus a third divided by 2 over 3, and finally the last term is just plus x. From 8 is the upper limit, and then 1 minus 8, and once we calculate this, we'll get 43 over 5 for the area.